In all, 9 questions were given from the topic functions from the chapter Differential Calculus. These 9 questions were given in the JEE Main exam held in January 2024 session. We have already covered the first 6 questions in 2 different videos. The aim of this video is to discuss the questions 7, 8, 9 in detail. This question has appeared in the JEE Main exam held on 31st January 2024 in the first shift. The given question is, if f of x is equal to 4x plus 3 by 6x minus 4, where x not equal to 2 by 3, and f compose f of x is g of x, where g is a function from r minus the element 2 by 3 to itself, then g compose g of 4 is equal to. We are given a function f and another function g is defined as f compose f, and required to find the value of g compose g of 4 from the given 4 options. This is a very simple question and it is suitable for TS Telangana State and Andhra Pradesh State EAP CET examination also. Let's now discuss the solution of this problem in detail. We have the given function f of x is equal to 4x plus 3 by 6x minus 4, where x not equal to 2 by 3. Note that the domain of this function f is r minus the singleton set 2 by 3. Why? Because for every x, f of x is defined except for that point where 6x minus 4 not equal to 0. When 6x minus 4 not equal to 0 will give you x not equal to 2 by 3. So there's the domain of this function is r minus singleton set consisting of 2 by 3. Agreed. We are given another function g of x as f compose f of x is equal to g of x. Right. Now obviously the domain of g of x is equal to the domain of f. Yes, because f compose f of x will tell you the domain of g is the domain of f. And the domain of f, which we have already seen, r minus the singleton 2 by 3. Anyway, the domain of g in the question itself they have given. That is g r minus 2 by 3 to itself. Anyway. Right. Now, let us see what is g of x. G of x is f compose f of x. So, f compose f of x is f of x. That means get into the function f of x. Wherever there is x, you write f of x. And that will be 4 times f of x plus 3 by 6 times f of x minus 4. Right. What is f of x? You write down. So 4 times f of x is 4x plus 3 by 6x minus 4 plus 3 by 6 into f of x is 4x plus 3 by 6x minus 4 minus 4. Now take the LCM and take the cat. And the LCMs are cancelled and you obtain this one. And when you simplify this one, you get 34x is by 34 and that is equal to x. So therefore, you get g of x is equal to x for all x belongs to r minus 2 by 3, because the domain of g is r minus 2 by 3. That means g of x, g acts as an identity function on r minus 2 by 3. Agreed. Now, g compose g of 4 is equal to g of 4. G of 4 is 4. Why? G of x is equal to x for all x other than 2 by 3. So 4 is other than 2 by 3. Therefore, you get g of 4 is equal to 4. So g of 4 is 4. That is g of 4 is equal to 4. So the answer is appearing against option 3. Therefore, the answer to this question is option 3, and that is the detailed discussion of the solution of this question, and it is a very simple question. Agreed. Now let's move to the next question. Right. This question has appeared in the JEE Main exam held on 1st February 2024 in the first session. Let f be a function from R to itself and g be a function from R to itself, and they are defined as f of x is equal to log x to the base e when x greater than 0, e power minus x when x less than or equal to 0. And g of x is defined as x when x greater than or equal to 0 and e power x when x less than 0. Then g compose f is a function from R to R is, 4 options are given. You have to discuss their nature, that is whether they are 1, 1 or onto. The 4 options regarding 1, 1 and onto are given to us. You are given f and g are 2 functions from R to R defined like this. And you have to discuss the 1, 1 and onto nature of g compose f. Let's now discuss the solution of this problem in detail. Right. We are given a function R to R defined like this, and we are given a function g R to R defined like this. Now, it is better if you know the graph of this function fx. So, we will draw the graph of fx roughly, and this is log x to the base e when x greater than 0. So from here to here. So this is the whole graph. And you have to notice that log x is positive. Log x is positive when x greater than or equal to 1. And log x is negative between 0 less than x less than 1. And e power minus x when x less than or equal to 0, and this is also x less than or equal to 0, e power minus x is like this. Agreed. If you know this graph, you can think of g compose f also. So e power minus x when x less than or equal to 0 will be what? Will be positive, and when x is equal to 0, it is e power minus 0, that is 1. So it is positive, and at one point it is 1. Now, g compose f of x is defined as g of f of x. And get into g of x, wherever there is x, you write f of x. That is f of x, x greater than or equal to 0, fx greater than or equal to 0, e power x, e power fx, f, and x less than 0, fx less than 0. So write down now. We will try to discuss very carefully where f of x greater than or equal to 0. First of all, it is e power minus x. First of all. And the domain for that is minus infinity to 0 included. And f of x is positive greater than or equal to 0, where f of x means f of x is ln of x. This is the ln of x, and when x greater than or equal to 1, this is the 1. And where is f of x is negative? F of x is negative, ln x is negative between 0 less than x less than 1. That is e power fx is ln x. E power ln x, 0 less than x less than 1. So this is the g compose f of x. And write it in an order. So this will be equal to e power minus x minus infinity less than x less than or equal to 0. And x 0 less than e power ln x is x, 0 less than x less than 1, ln x 1 less than or equal to x less than infinity. So minus infinity to 0, 0 included, 0 to 1, 0 not included, 1 not included, 1 less than or equal to, that means 1 is included up to infinity. So that means G compose F defines from R. So the domain of G compose F is R, right? And here G compose F, the composite function, the codomain is given to be R. That is very important for us. Codomain is given to be R. To discuss on to this is required. So let's now talk about one and on to nature of G compose F in the next slide. Right. So we have F, we have G, and we also have G compose F, which we have seen in the last slide. Right. Now what I observe is, if I take x is equal to 0 here, x is equal to 0, then it will be e to the power of minus 0, that is equal to 1. So G compose F of 0 is 1. Also, when I take x is equal to e, so certainly 1 less than or equal to e less than infinity. So e is greater than 1. Therefore, e lies in this. Therefore, ln of e will be 1. That means G compose F of e is ln of e, that is 1. That means two different elements, 0 and epsilon in the domain, they are giving to the same image, namely 1. So notice that G compose F of 0 is e power minus 0 is equal to 1. G compose F of e is equal to ln of e is 1. So therefore two different images, that is 0 not equal to e, are mapping to this same element 1. Therefore G compose F is not 1 1. Agreed. Now how do we say that this G compose F is either onto or not onto? How do we say that? Now, for minus infinity less than x less than or equal to 0, when you take x is equal to minus infinity, e to the power of minus infinity, that is e to the power of infinity, that is infinite real number, to x positive real number, infinite positive real number, x less than or equal to 0, that means e power minus 0, that is 1. So that means all positive real numbers greater than or equal to 1 are the images of that one. And in the second one, for 0 less than x less than 1, the images are 0 less than x less than 1. And this is up to minus infinity to 1 it has come, and it is 0 to 1, and 0 and 1 are not included. ln x, what are the images? For 1 less than or equal to x less, ln of 1 is 0, ln of 1 is 0, and ln of infinity. So that means what are the images? All the images. What are all the images? All images are all positive real numbers including 0. So all the images means the range of G compose F is all positive real numbers including 0. That means non-negative real numbers. So this is the range. Is the range equal to codomain? Codomain is R. Codomain of G compose F is R. So it is only a part of R. So that means the negative real numbers are unmapped from the codomain. From the codomain, negative real numbers are mapped. That means for any negative real number that you take in the codomain, you do not find a pre-image for that. Therefore, G compose F is not onto. So G compose F is not onto because the range is R plus union 0, that is non-negative real numbers, which is not equal to R, which is the codomain. So the range is not equal to codomain, and hence it is not onto. So our conclusion is G compose F is neither 1 1 nor 1 2. These two conclusions you can as well draw from the, if you can draw the graph of G compose F. So let's see G compose F. How do we get the information? For this, that is e power minus x, and this is x, this is ln x. This is the portion. Now, if you draw y is equal to 1, a line parallel to x-axis, and it is intersecting the graph at exactly 2 points. Those 2 points are x is equal to 0 and x is equal to e. And that's what we said. G compose F is not 1. If you can draw any line parallel to x-axis, y greater than 1, anyone if you draw. So you can draw like this also, it intersects. Therefore it's not 1 1. And it is not onto because the codomain is all real numbers, all positive real numbers including 0. So that means including 0, this is the 0 point, and these are all the things. This is the one, this is the one. So therefore this is r plus dot, and the negative real numbers are unmapped. Therefore the range is not equal to codomain, and hence it is not onto. So thus our conclusion is the G compose F is neither 1 1 nor onto, and we have the 4 options, and our conclusion appears against option 1. Therefore the answer to this question is option 1, and that is the detailed discussion of the solution of this problem. It is in one way easy, but not very easy. It's easy provided you have this knowledge of these functions and the knowledge of the graphs. Anyway, we will move to the next question. Now this question has appeared in JEE Main exam held on 1st February 2024 in the second shift, and this will be the last question on functions in this video. The given question is, if the domain of the function f of x is equal to under the square root of x square minus 25 by 4 minus x square plus log of x square plus 2x minus 15 to the base 10 is the open interval minus infinity to alpha union semi-closed interval beta to infinity closed at beta end. Then alpha square plus beta cube is equal to. So we have to find the domain of this function. That domain will be of this form: minus infinity to alpha open interval union beta to infinity the semi-closed interval closed at beta end. Then you will obtain alpha and beta and compute alpha square plus beta cube, and we are given 4 options. It's also a simple question. We have the function f of x is the first function plus the second function, right? F of x is equal to g of x plus h of x, and we know the domain of f of x is equal to the domain of g of x intersection with the domain of h of x. So we write that way. So first of all, we attack the first one, the domain of the first function, that is under the square root of x square minus 25 by 4 minus x square is equal to the set of all those real numbers x such that x square minus 25 greater than or equal to 0. Why? Because if x square minus 25 is less than 0, this is undefined in the set of real numbers, and we are considering functions on the set of real numbers, and if it is x square minus 25 less than 0, it is negative. The square root of negative is imaginary, which is not there in real numbers, and hence to have this is defined whenever x square minus 25 greater than or equal to 0, and this is defined whenever 4 minus x square not equal to 0. If 4 minus x square is equal to 0, the denominator becomes 0 and the function is undefined. anyway. So this is equal to the set of all those real numbers x such that x square greater than or equal to 25 intersection end, because of the end. All those real numbers x belongs to R, x square not equal to 4. So this we have written as x plus 5 into x minus 5, and x square not equal to 4 is x not equal to minus 2 and 2. So this is repeatedly we are getting this kind of situations, and we have done in earlier problems also. So we take a real number line and minus 5 plus 5 is identified here, and when x greater than 5 it is positive, and it is negative, it is positive, it is negative in between minus 5 to 5 and positive in minus 5, and it is greater than or equal to 0. Because it is greater than or equal to 0, it is minus infinity to minus 5 closed at minus 5 and 5 to infinity closed at 5 n. So that is equal to this one, and this is intersection R minus the two elements minus 2 and 2. So other than these two elements, all real numbers. If you take the intersection, and you will see minus 2 and 2 are not there in the first interval. So also minus 2 and plus 2 are not there in 5 to infinity also. If you take the intersection, you will get these things only. So that is minus infinity to minus 5, union 5 to infinity. Agreed. We move to the domain of the second function. So the domain of the second function is the logarithmic function, and the domain of log of x square plus 2x minus 15 is set of all the real numbers x belongs to R such that x square plus 2x minus 15 greater than 0. That is, set of all those real numbers x belong x such that x plus 5 into x minus 3 greater than 0. It's very familiar, and you catch hold of a 3, catch hold of minus 5 and 3 on the real numbered line. See whether x plus 5 into x minus 3 is positive. Where it is positive, you see. So this is minus 5, this is 3, and when x greater than 3 and this x plus 5 into x minus 3 is positive, negative in this interval, positive in minus infinity to minus 5, and it is greater than 0, therefore open intervals you will get, and that is minus infinity to minus 5 union open interval 3 to infinity. So thus we got a logarithm of a domain of the logarithm of x square plus 2x minus 15 to the base 10. Agreed. Now we got the domain of the first function, domain of the second function. Take the intersection from 1, you get the domain of fx. So domain of fx is equal to the domain of the first function is this one, the red one. Intersection, the domain of the second function is the blue one. It is, you think like this. This is A intersection B union C, and use the distributive law. A intersection B union A intersection C. So A intersection B union A intersection C. Now you see minus infinity to minus 5 open interval completely lie in minus infinity to minus 15. Their intersection will be minus infinity to minus 5, and 5 to infinity and minus 5 to minus infinity to minus 5, they are disjoint. Therefore, from this first one you will get minus infinity to plus 5 open interval, and here minus infinity to minus 5 union 5 to infinity, minus infinity to minus 5 intersection 3 to infinity. They are empty because these are all negative, these are all positive real numbers. And 5 to infinity intersection 3 to infinity, smaller of these two, 5 to infinity, closed at 5n. So this is minus infinity to minus 5 open, and 5 to infinity semi-closed, closed at 5n. But this is the domain of fx is given to be minus infinity to alpha open interval union semi-closed interval beta to infinity closed at beta n. This is given. So comparing, you will get alpha is equal to minus 5, beta is equal to 5. Now we want alpha square plus beta cube, And when you compute minus 5 square plus 5 cube, that is equal to 25 plus 125, that is equal to 150. Let's look at our options. Our answer 150 appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of these 3 questions, question numbers 7, 8, 9, from the topic functions and from the chapter Differential Calculus, that have appeared in the JEE Main examination held in January 2024 session. I am sure that you have understood the solutions of these 3 questions, and I wish you all the best. Thank you.